All right, welcome to Unit 5, the last unit in Semester 1. Woo! Celebration. All right, so we're looking at systems of linear equations. Fun stuff. So just so you know, another reminder, we've got this planned up until December. So if you feel that you're going to be absent one day, or if you are absent, remember to always check this calendar, because I would say for the 90% of the time, we're going to stick to this. And also be sure to use your checklist. There are some new things on the docket that we haven't had in a while. For instance, we've got a comprehension check that we'll have coming up for substitution. This is also, you can find this on the calendar, as well as a comprehension check on elimination. So 2 comprehension checks this unit. So I want to start by reviewing how we graph. So looking at our Ignite, which I want you to look at it as a review, not Ignite. To graph, we want to make sure that y is by itself, and so we divide everything by 3. In doing so, y is now by itself, and I get y is equal to, now this becomes 1/3, or in fact negative 1/3, x, and then plus 3. So now it's in the form I like. I can now graph that starting with the y-intercept, so it's at 3, and I'll go down 1 and over 3. Down 1, 1, 2, 3. Now I'm going to do one more, so down 1 and over 3. And go ahead and connect my points with arrows on the end. So we reviewed this because we're primarily, actually fully, going to look at graphing in this video. So we're going to talk about, like I said, the whole unit's about systems of equations. And so a system of equations is simply put two or more equations with the same whoa. Whoops. That's kind of a weird looking M. Okay, now I gotta remember how to erase this. Okay. Yep. Okay, with the same unknowns. Which is like a fancy way of saying like the same variables. So here's an example. I might have the equation 2x minus 1y is equal to 9. And then 5x minus 1y is equal to negative 2. And we're going to be solving for both x and y. And that's where our next vocabulary word comes into play here, is a solution is an answer to the unknown variables and that holds, so basically it's an answer to the unknown variables. Let's say, I'm going to erase this again. Simply put, in both equations. So in both equations. Okay. And so one strategy to solving a system is to solve by graphing. And I mentioned this yesterday. When we graph a linear equation, such as the one we have up here, okay? So every point on that line, so every point on a line is a solution, okay? Whether it be a decimal or whole number. And so if we graph 2 lines, if they intersect, then that tells me that they share the same set of ordered pairs, right? And so here we have, down here, we've got exactly one solution. Then here we've got an infinite. It would be the same exact line then. They're laying on top of each other. And then this is no solution, so they're parallel. They'll never hit each other, therefore they're never going to share an ordered pair or solution. So in the first example here, it says determine how many solutions the graphs have, and then say what the solution is. So in A, I can see that my solutions right here, this is where they're hitting each other. So I would say one solution. And specifically, it is the point 2, let's see, let's count 1, 2, 3, 4. So 2, 4. Then here they are parallel again, so that would be a no solution. I don't know if I can make this smaller. There we go. No solution. And then here in C, I can, it's probably harder for you guys to tell. Come on, let's zoom in. If you don't know, I'm just trying. Well, it's not letting me zoom in. That's not cool. Anyways, this it's two different lines, but they're on top of each other, so we say that's infinite solutions. So let's get some practice with graphing and identifying the solution. So in example A, so my first step is to make sure, okay, it's slope-intercept form, okay, we're good to go. So I'll go ahead and plot the points. So there's 1, and it's a negative slope. Now the thing is with this unit is we have to plot as many points kind of as possible or that we feel is enough because we don't know where these lines are going to hit each other. So there's my first line. I'm hoping that's enough points. And then I'll graph this one in red. So here we go, there's 4. Oh, and I notice that they're parallel. So because they're parallel, and I honestly should have seen that because they have the same slope, but they're parallel. And because of that, we would say then no solution. So no solution. All right, let's look at example B. So the first equation, we're good to go. So I'm just gonna go ahead and I'm gonna graph that. So I go to 3 and I go up 2 and over 1. And then I'm also gonna go down 2 and over 1. Again, I don't know where these are gonna hit, so I'm gonna do as many points as possible. Now the second equation is not in slope-intercept form, so I need to get y by itself. So I'm subtracting 8x to both sides. And then, excuse me, and then I'll divide by -4. And I get that y is equal to 2x plus 3. Huh, interesting. That's the exact same equation that I have up here. And so basically, we're going to share all these points. Therefore, okay, we would say infinite solutions because it's the same equation. Looking at example C, so it's nice. They're both in slope-intercept form. Let me go ahead and zoom up on this. So I'll start for this guy, I'm going to start at 5, and I go down 1 and over 1. Again, putting plenty of points because I don't know where they're going to intersect. I'm kind of hoping like that's enough. And then I'll plot that guy in red. So we got -6, and I'm going to go up 4, 1, 2, 3, 4, and over 7, 1, 2, 3, 4, 5, 6, 7. Now I can see that I didn't plot enough points in blue, but I know that it's going to also share that point, so that's my solution. So my answer then is going to be, let's see, that looks like 7 and -2. And you know what? That's going to bug me if I don't connect the lines. There we go. All right, so let's look at D. So the first equation is not in slope-intercept form. So I'm going to go with subtracting x to both sides first. And that gives me -6y minus x plus 6. Whoa, hold on. I made a mistake here. Gotta remember how to erase. Here we go. Okay, so -6y is equal to, forgot the equal sign. Now I'll divide everything by -6. And so my new equation is y equals, this will change to positive 1 over 6x, and then this is going to change to -1. So I'll start by plotting that -1 and go up 1 and over 6, or down 1 and to the left 6. All right, and then my second equation is in slope-intercept form. Now, let's think about this. When I go to graph the slope, okay, the slope is 7 over 6, right? Obviously, I can't go up 7 and over 6, and even if I could, I know it's not going to hit the blue line if I go in that direction, so I'm not going to waste my time. Instead, I'm going to go down 7 and to the left 6, and let's see, where is that going to put me? So down 7 and over 6, it shares that point right there. That's my solution, and that is the point -6, -2. All right, on to the next one. Maybe at this point you want to try this as on your own because you're starting to pick up what I'm putting down. That would be great. All right, so your first step is to get these equations in slope-intercept form. So the first step I would do is I would have subtracted x to the other side. Whoops. And so that gives you -x. Oh my goodness. Stinking gracious. You know, I tell you, at least I'm catching my mistakes, right? All right, so let's try that again. So minus x minus 6. And then I'm going to divide everything by negative 2. And so I get the equation y is equal to positive 1/2 x plus 3. So I'll go ahead and graph that. My old eyes need this to be zoomed up. All right, here we go. So 3 and up 1 over 2. Again, as many points as we feel is necessary. You really only have to do it with the first one, right? All right, there's my line. And then for my second equation, I would start with subtracting x to the other side. I have 4y is equal to negative x plus 36. Divide everything by 4. And we get y is equal to negative 1/4 x plus 9. So I'm going to go to 9. So right here. Go down 1 and over 1, 2, 3, 4. Down 1 over 1, 2, 3. Luckily I plotted that point. And let's see, that's the point. 6, 7, 8. Looks like 8 and 7. All right, last one. I like this one because it gives like a little reminder of Vux and Hoy. So that's Hoy because I only see y. So it's just a horizontal line passing through 5. And then the other equation is nice enough to be in slope-intercept form. So I start at negative 9, which is right here, and go up 7. So let's see, 1, 2, 3, 4, 5, 6, 7 over 2. You know, this, I'm going to be totally honest with you guys, this unit is really easy to make really small mistakes, especially with graphing. So let's see, I'll go up 7, 1, 2, 3, 4, 5, 6, 7 over 2. So it's important to be meticulous and take your time. All right, so I see they share this point right here, which is the point 4, 5. Which makes sense, okay, because it literally tells you y is 5. So there's a dead giveaway. And finally, of course, we couldn't not do a word problem. So an example for it says Mariah and Diego love to ride bikes. The equations below show the number of miles they ride. M, based on the number of weeks. W, predict the week in which Mariah and Diego will have ridden the same number of miles. So first, I'm going to zoom up on my graph because it's so tiny, but you guys should have the information in front of you. So I know that this is going to be the number of weeks, right? And this is going to be miles because, whoops, oh geez, let me move this over. The miles depend on how long we've been riding for, right? So I'm going to be able to go up by 1s here, no problem. I don't think we'll have to go up more than that. But I think it'd be a good idea to put a break in our graph, and we'll start at 20. And let's go up by 5s because the slope for one of the equations is 5w, or 5. So I'll go up by 5. So I'm skipping 1, there's 30. Skip 1, there's 40. Skipping 50, and 60, and 70. So what I'm going to do is I'm going to graph the first equation in blue. So I'd start at 20, and I'm going up 15, which is equivalent to going up 3, right? So 1, 2, 3, and over 1. 1, 2, 3, over 1. I think that's enough. And then I'll do the second one. I'll do that one in green. So that guy is starting at 50 and going up 5 and over 1, up 5 over 1. They intersect right there. That's where they share the point. So that's my answer. And that answer is going to be 3, 65, or 3 weeks and 65 miles. So that means on week 3, they will both have gone on their bike rides or ridden 65 miles. So at this time, try 1 and B on your own. All right, so for 1, the first thing you want to do is subtract the x over. So you get negative 2y is equal to negative x plus 4. Divide everything by negative 2. And we get y is equal to positive 1/2 x minus 2. So I start at negative 2 and I go up 1 and over 2. And I'll, just to be cautious, I'll go down 1 and to the left 2 just in case. All right, I think that's plenty. And now I'll do the second equation. So I'm going to start by subtracting the x over. So I get negative 2y is equal to negative x minus 2. Divide everything by negative 2. and that gives me y is equal to positive 1/2 x plus 1. And right off the bat, I see that I have the exact same slope. So that means I've got parallel lines, so that means no solution. All that work just to realize that there's no solution. And then finally, Alex and Amber are both saving money for a summer vacation. The equations below show the amount they will save depending on how many weeks. That literally tells you A depends on W, by the way. So that means that the amount, or I'm going to say, we'll put money over here. And we'll put weeks here. And again, I can go up by ones for my weeks. And now, because I've got some pretty large y-intercepts, I'm going to put a break in my graph. And I'm going to start at 75. And I think it would be a good idea to go up by, let's do 5s. Because I see I have slopes of 5 and 10, so that would make the most sense, right? So this would be 80 and then 85, 90. So I'm kind of just going every other one. And I'm able to fit up to 130. So I'll go ahead and graph the first equation in blue. So I start at 100. I'm going up 5 and over 1. And then the second equation I'll do in green. So I start at 75 all the way down here. And I'm going up 10 or up 2 over 1. And I find that they share this point right there. So that's the point. Let's see, let me arrow down here. That's the point 5. So 5 weeks. So in 5 weeks, they will both have $125.